Hello everyone, we're going to be talking about the NumPy library today, and we're going to be seeing some intrinsic creation of an array after we looked at how to create an array. And we're also going to see how we can join arrays together, the basic operations, how we can split arrays, and how we can also save and load an array. Okay, so first of all, I would like to tell us what an array, a NumPy array is. A NumPy library. A NumPy library is a basic package for scientific computing with Python and especially for data analysis. Now, for those of you that want to go or venture into the field of data analysis or data science, and NumPy library is one of the library that you must know, that you must get acquainted with. And one of the reasons for this NumPy library is because NumPy libraries helps in large computing of mathematical and scientific data. Okay, so we are going to look at the features of this array. So as we go further, I would like you to pay good attention. Okay, so now we start by, first of all, for you to start working on this library, you have to first of all import the NumPy library. Okay, so we start by saying import NumPy as NP. Now this NP is an alias. Okay, so now this is how to create an array. Now let's say we want to create an array. Let's say first we call it first array. Okay, is equals to, now the first thing you're going to do, now this alias here is NP, you're going to say NP dot array. Now put the bracket here and we'll put a square bracket. Now I want to start by naming an array. Let me say I have an array of 1, 2, 3. Okay, now I've created this array, so I will run. First of all, here we have to run this. Second, we have to run this we have created to see, okay, I didn't throw us an error, so we are sure that we can go on with this. So I write first array. Now I want to call this to so that we can view this. Okay, view the array. You can see it's a one-dimensional array. So we go further now. We want to check how do we know an array is one-dimensional. And I do, okay, let me let you know that a NumPy array is an n-dimensional array. What n dimension means? Multiple dimensions. Okay, so now how do we know the dimension of an array? What we'll do, we use the n dimension function. Okay, now first of all call our variable holding the array. Okay, so we use the dot n dimension attribute. Okay, so now we run it. Want to see so now let's run. Now you can see this array is a one-dimensional array. Okay, so okay, let's say in the case maybe we're having a two-dimensional array. Let's create two-dimensional array. Let's see equals to mp dot array bracket. Okay, now let's see, because it's two-dimensional array, we'll still start another square bracket. So we'll say 1, 2, 3, then come out here, comma, put another array. Let's go. We say 4, 5, 6. Okay, now let's run this. Okay, that's worked. So let's call it first array 2. Okay, so let's run it. You can see now we have another form of array. So now let's see how this works. Okay, now let's see how many dimension is that. Found out that the first one we created is one dimension, so I want to check this one to see how many dimension. So we'll say dot, use the n dimension attribute. Okay, so let's check it, run it. Now you see it's a 2 dimension. You can see the first axis, the second axis, showing us that it's a 2 dimension. So you can create more dimensions. Okay, so that is how to look for the dimensions. Now we'll go on to check for the shape of an array. Let's check for the shape of first array. So we'll say dot, we use the dot shape to check. So let's run. You see, it will return us a tuple. Okay, this is the first array which we created up has a shape of 3. Now this is what it means. You can see it has a shape of 3 elements, okay, in the array. So now let's check for the shape of the second array we created. First array 2. So let's do dot shape. Okay, and let's run. Now you see it has returned us a tuple 2, 3, telling us that 2 rows and 3 columns. Okay, and another interpretation of it is it has 2 rows, or it has 2 axes and what 3 elements in each. Okay, so now we want to look at the size of the array. Now how to look for the size? Let's check. Use first array dot and use the size attribute. Okay, so use the size attribute to check. So the size simply means the length. Okay, so now let's check for that of the other array. First array 2 dot size. Okay, so okay, now let's run it. Now you see it's 6. So size, the attribute size tells us about the length. Okay, you can see the length of this second array is 6. That's why it's giving us 6 here. So you can count it 1, 2, 3, 4, 5, 6. So size talks about the length of an array. Now we'll move further to the intrinsic creation of arrays. Okay, now I want to see how we can generate generate or fill up an array automatically. Okay, so now this is how we can actually. So okay, we start with the 0 function. Now the 0 function creates a full array of zeros with dimension defined by the shape argument. Okay, now for example, let's try to create a 2-dimensional array, okay, of zeros. So we'll say np dot zeros. We use the zeros function. Then we'll put inside it, we'll put a tuple of the shape we want. So let's say we're doing 3, 3, that is 3 rows, 3 columns. Okay, so we'll run this now and we'll see. Now you see we have filled up the array with just zeros. Okay, that is how you can also generate an array. Okay, now I want to see how we can fill an array with ones. Okay, let's see by using the dot ones function. Then let's define the shape. Okay, let's say we still want to create an array of ones with shape 3, 3. You can give it whatever shape you want. In this case, we're using 3, 3. Okay, now we can also get another way of generating array, which is called the arrange. Okay, this function generates NumPy array with numerical sequence that respond to a particular rule depending on the argument you pass on it. Okay, so let's explain what that actually means. Now we're going to generate an array, and we'll specify 2 arguments which we have to give an interval. It's a kind of interval, okay, for us. Okay, so let's see. We use the dot arrange. Now this will generate an array for us between a given interval. Okay, so we we'll pass two arguments. So let's say we want to generate an array between 0 and between a range of 0 to 10. Okay, so comma 10. So let's see what this will give us. You see, okay, we generated an array from 0 to 10. Now, mind you, the second argument in this arrange function will not be included, but the first argument will be included. You can see from 0 to 9. So it's between the interval of 0 to 10. Okay, so now this is how to generate. We can also generate more of that. Let's see. You can say okay, mp dot arrange, then let's pass an argument. Let's say from 4 to 20, or okay, to 20, and we'll run it now. Run it to see what we'll have. Okay, you can see from 4 to between the interval of 4 to 20. I told you the first argument is inclusive, while the second argument is not inclusive. So let's move on to the other function. Now we have the line space function. Now what does the line space function do? The line space function is similar to the array function, but in this case we'll be having three arguments, and the third argument will specify the distance between one element and the next element. Okay, so now let's see how this goes. So you say mp dot line space, now we'll find the argument. Okay, so we say it's going to have three arguments. Let's say from the first two arguments is the interval. Okay, then the third argument will specify the distance between one element and the next. Okay, the third argument, okay, will specify the interval to be splitted. Okay, so while the first two arguments will just give us the distance between the numbers we want to display. Okay, let's say between 0 and 10. Then the third argument we'll be writing now will help us define the number of elements between that range we want to output. Okay, let me say 5 numbers between the range of 0 to 10. Now Python will share it equally, okay, so that we'll have a fixed amount of sequence. Okay, amount of number 5 numbers, 5 elements, 5 numbers between 0 to 10, but it will give us in a particular sequence. Okay, all right, now let's run this. You can see from 0 to 10, you can see from 0 to 2.5, at 2.5 we give you 5, 2.5 75, like that. So move to the next function, which is what? The random. Now this random already we'll be seeing another method to obtain an array already containing values. Okay, but this function now, what it does is it fills them with random values. Okay, it will fill the array with random values. All right, now let's see how this can be done. Okay, let's say the mp dot random. Okay, so now we'll specify, we can pass one argument into it, we can pass the shape into it. So now let's say we want 4. So run, you can see if I still run this again to give me a different number from this. Okay, you can see it changes. Okay, now we can still use the shape to define it also, to define the numbers we want to put. Our random bracket, so we'll specify the shape by putting under bracket. And let's say we want 4,4. Okay, so we want 4 rows, 4 columns. Okay, so now let's run this. Now you see it, see the output here. See what we're having here: 4 rows and 4 columns. Okay, now before I forget, there's another one more thing we have to do. We can see how we saw how we used the range function to specify a range of values that we want to output. Okay, now you can also use the range function together with reshape function. Okay, this is how to manipulate arrays. Now we'll see how we can apply the range function and the reshape function together. Now maybe I want to generate an array of a range of let me say 0 to 12, 0, 12. Okay, now I want to reshape it. I will do the reshape in our last class. You can refer back to my other video. I'll put the link down below. Okay, now I want to reshape this now. I want to reshape it. I want to give it another shape. So I can specify. I can say, let me say 3, 4. Now, whenever you are reshaping, you should note that the multiple of what you are reshaping should collaborate with the range. Okay, so now I am applying the range, which is telling us the interval. So it will output number between a range of 0 to 12, and 12 will not be included. Then we'll reshape it to 3 rows and 4 columns. Okay, now let's run this. Now you can see it didn't exceed 12 and it's having 3 rows and 4 columns. Okay, so now we will move to the basic operation. Okay, now look at the basic operations in a NumPy. Okay, so we'll be starting first of all with the addition operation, the arithmetic operation. We'll start with the addition and we'll do the multiplication. Okay, so let's start with the let's say arithmetic operation. Okay, sorry, typing nothing here. Operation. Then okay, so now we'll be starting with the sum. Okay, now let's generate an array called A. Let's generate using our intrinsic function, which is a range. Let's generate an array of 4 values. Okay, that will not exceed the number 4. Okay, so let's just call it immediately. Then now you can see we've generated an array of 4 elements. Okay, so now we can use a scalar value. We can add a scalar value to an array. Okay, let's see how we can do that. Let's say our array is A, then we can add a scalar value to it. Let's say we'll sum it to 4. Okay, now you see 4 plus 0 equals 4, 4 plus 1, 5, 4 plus 2, 6, 4 plus 3, 7. Okay, so now let's apply the multiplication. Okay, let's say A multiply by 2. Let's see what it will give us. Okay, we got our answer. And this, you can see, I can explain it. 2 multiplied by 0 give us 0. 2 multiplied by 1 give us 2. 2 multiplied by 2, you can see. So this is how this works. Okay, now we can also add 2 arrays together. Okay, now whenever you are adding 2 different arrays together, you make sure that the shape of those arrays are the same. Okay, the lengths are the same as well. Okay, now let's create an array called B. Okay, B. Okay, let me use an intrinsic function range to generate this array. Let's say between 4, 8 is the interval I want it to give us. So now let's indicate B here. Let's run it. Now you see what this array B is holding. Okay, it's holding this value, the same shape with the A, the array A we did here. So now let's see how we can add two arrays together. So let me comment here, sum two arrays together. Okay, that's A plus B, to sum them together. So you can see our array A plus array B give us this. Okay, so now let's see another operation. Let's say subtract array A from B. Okay, so now let's say A minus B S1. You can see, so you can also apply multiplication to two arrays. Okay, so now let's see how this goes. Okay, so now let's say A times B. Okay, so now you see the answer we got. Okay, so now let's move. Okay, let's move to the next. Now, okay, there are some inbuilt functions we can also apply to these things. Okay, we can also say A times the sign of B. Okay, we can also say A times the sign of B. Now let's see what it will give us. So you can see the answer. Now lastly, we can also do A multiplied by the square root of B. That everything inside the array B squared. That is the square root of everything inside array of B we specified up there. So let's see A multiplied by, then we use the NP, the square root inbuilt function, because that is the function that can give us the output of square root of a number. So let's say B. So now let's run this, and you can see this is the output. So now we can move to other things. Okay, we can see how we can apply some other things to the array. And now before we do the join, okay, join array, let's take a look at some things here. Okay, let's take a look at some. Okay, let me see B. Okay, now let's see how we can access elements in an array. Okay, let's say we are creating an array. A is equals to mp dot a range, let's say 10, 16. Okay, so let's see how we can do this. Now you can see. Now I want to see how we can access. Let's say we want to access 14, and 14 here. Now we start counting from the index number of 0, 0, 1, 2, 3, 4. Now this is 4. So we'll say, call the variable name, then we'll place as a square bracket, then we'll say 4. Now let's run it and see 14. That's how to access. You access it by the index number. It starts from 0. Now we can also access it in another way, from behind. If you're accessing it from behind, it's the negative, it will carry the negative sign. So 15 has a -1, -2, like that down. Okay, so now let's see how we can access 15. Okay, let's say A square bracket -1. So we are counting from here, so let's run it to output 50 and like that. Okay, so let's move further. Now you can see, let's see how we can join two arrays together. Let's see, we'll see how we can join two arrays. We'll start with the v stack. Okay, we'll start with the v stack. Okay, let's see. And what does the v stack function do? It combines the second array as new array of the first array. Okay, so we can see how we will join two arrays together. We've created two arrays here. Array A, capital letter A, which shows that the ones function, and the capital letter B, which will display the zeros function into 3, 3. Same thing with the second array we created. So now let's run it. Let's run it to see. Okay, we've run it. So now let's see how we can stack them up. Okay, before that, let's view them. Let's say A. Let's run it. A contains array of ones. B, let's see, B contains array of zeros. Okay, let's see how we can apply the vertical stack, which we call the V stack. How we can stack them up together by joining the arrays together. I told you the V stack function combines the second array as a new row of the first array. So let's see how that is being done. Now let's say np dot vstack bracket. So we'll now put under bracket to indicate the two array we are using. So array A and B, want to join them together, want to stack them vertically. So as this is like this, want to still add another one under it. So let's see how we can stack them vertically. You can see, so the second array is attached to it to continue the row of the first array. Okay, now we have another way we can join an array together, two arrays together. Now the other way is to use the H stack, which means the horizontal stack. Okay, so now let's do np dot H stack. Okay, now we indicate the two arrays we are stacking. So let's run. So you can see we're stacking it horizontally. It performs a horizontal stacking. That is, the second array is added to the column of the first array. See, the second array is added to the column of the first array. So that is how to join. Okay, so now we'll be looking at another operation here. Down here we'll talk about splitting. Okay, we will see how we can split arrays together. You can see how we can split arrays apart. Okay, now let's start by let's create an array called A again. So let's see, I'm using the one of the intrinsic way of generating, which is the A range. Now let's see, maybe I want to apply 16, a range of 16. Okay, now I want to reshape it. I can reshape it. Okay, let's reshape it, and make sure whenever you are reshaping, you have to put the shape in the multiple of what will give us 16. Okay, let's say 4 by 4. Okay, so let's run it. Let's display A. Let's run it. You can see interval of between 0 to 16. So give us the interval. So we shaped it into 4 rows and 4 columns. Okay, now let's see what this will give us. Now I want to split it into 2. Okay, I want to split it into 2, and I have to label the values of what I want to split it into. That means I want to split it into E and F. This is separate variable for the arrays I want to divide this thing into. Okay, so now let's see, is equals to np dot, I want to split it horizontally. Okay, I want to split it horizontally, and if you want to split the array horizontally, meaning the width of the array divided into parts, the 4 by 4 matrix will be splitted into 2 by 4. Okay, so I want to split it into 2. So I say np.hSplit. I want to apply the hSplit on it. Now, first I have to indicate the variable holding the array I want to split, and which is a, which was displayed here. So I say a. Now, comma, the next argument I'm going to enter is the part in which I want to split it into. I want to split it into 2 parts, which I've defined the 2 parts variables here. I want to split it into. So right now I will have to run. Then let me first call the first one, which is e. I run. Okay, you see that's shared this array into 2 horizontally. Okay, horizontally. You see how it's horizontally. You just divide, give this part out, give this part out. So let's see for f. Let's see. You see. So that is it. Okay. So that is how to split an array horizontally using the hSplit. Apply the vertical splitting. Okay. Let me add this. You can also add the vertical splitting, which you can use the np dot. Okay, before we do the vertical splitting, we still have to indicate the variables. Okay, we'll put it inside square bracket. The variables we want to split into. Let's say we want to split into q, comma p. You can indicate whatever variable name you feel like. Okay, so is equals to, let's say, np dot vsplit. Then first of all, you indicate the want to split that variable. That array a we created at first. Okay, I want to still split it into 2. Okay, so now let's run and see. Okay, there was no error. So now let's call q. Okay, see vertically that's splitted it vertically. You can see this is vertical, so we shared it from here. Okay, vertically. So this up one goes, this down one goes. So vertically. So now let's see for p. See what p will give us. Okay, so you can see that split it vertically. So now lastly we're going to be looking at how we can load and save data in binary files. Okay, now maybe you have an array that you want to reuse. Maybe whenever you're working, maybe you created it and you don't want to, and you just want something you can call whenever you need it. Okay, so we can save array and we can load it when we want to use it. Okay, so we'll see how we can apply that. Okay, so let's see data. Okay, give it the variable data. Let's say np dot a range. Let me say. Okay, let's say random. Let's generate a random number. Random. Okay, let's say 16. Then coming here we say dot reshape. To reshape it to 3, okay, sorry, so the multiple is okay. Oh, it's showing us that cannot reshape array size 14. Okay, sorry, I was supposed to put 16 here. That's why I told you the multiple. You should indicate the multiple. So now let's call on the data. Now you can see random data has been generated. Okay, now let's see how we can save this. Array. Okay, the way to save it is by saying that let's give it a let's say np dot save. This is the function used in saving it. Np dot save. Then you indicate the name you want to save it. Let's say save data. say save data should be the name. We want to save it as it has two arguments. One, the name which you want to save it as, then the name of the data you want to save. Okay, so now let's run this and see. Okay, didn't throw us an error. That means it has been saved. Now, to recover this data whenever I want to use it, there's a way to recover it. So we want to load it. Let's give it a variable load. Okay, let me say loaded data. Okay, so is equals to, okay, we say mp dot load. This is the function to use, mp dot load whenever I want to call it. Okay, so call it by the name you saved it with. I say save data, and as you are calling it, you call it with the extension .mpy, which means NumPy. Okay, so now let's run this. Okay, didn't throw us an error, means we are correct. So now let's call it and let's act as if we want to use it. So let's call it. Okay, let's run. You can see the same data here, the same data. So that is it. You can see the things we can do with this NumPy array. Okay, so that is that. Thank you for your audience. Thank you very much. Okay, and I'll be doing another diving into pandas library. Okay, so that's where we'll start analysis fully. So you check out my other video on pandas. So, and again, I want to see your comments. I want to see you like and subscribe to the channel, so that I can be giving you more of info on data analysis, bringing to your way more ways in which you can improve your data analytics skills. Okay, thank you very much.